A family consists of a husband, wife, and their two children. When their first son was born, the average age of the family of three people was 20. So we'll just represent all that data here. This is the instant at which their first son was born. You have husband, wife, and their first son S1. So three people are there and their average was 20. So let us calculate the total sum. 3 people into their average 20. So their total age is 60. Some years later, when their second son was born, the average age of the family, now we have 4 people, became 21. So when their second son was born, you have husband, wife, S1 and S2 also. Now S2 is actually equal to 0 because he is just born. And when their second son was born, now you have 4 people and their average is 21. So 4 into 21. So their total age is now 84. Identify the age of the eldest son, that is S1, at the moment when their second son was born. Now this is the instant at which the first son was born and this is the instant at which their second son was born. And from 60 to 84, the total sum has now increased by 24. Now, how can the total sum increase by 24? S2 is actually equal to 0. That is, each of these three, husband, wife and son 1, all three of them should be 8 years older. So here it will be plus 8, here it will be plus 8 and here it will be plus 8. 8 plus 8 plus 8, the total sum has increased by 24. So each of them should be 8 years older. So which means that the second son was born 8 years later. So when the second son was born, the first son will be 8 years old. Hence option B, 8 is the right answer. In a zoo, there are some rabbits and pigeons. So rabbits are there, pigeons are there. If the heads are counted, there are 200. So each animal will have only one head. So total number of animals is 200. So if you assume that the number of rabbits is x, then the number of pigeons will be 200 minus x. So that x plus 200 minus x, total is 200. So altogether 200 animals are there. Now the question is, if the legs are counted, there are 580. Now for each rabbit there will be 4 legs and for each pigeon only 2 legs are there. Now let us assume that the number of pigeons is 200. If the number of pigeons is 200, then the number of legs will be 400. That is, just assume that there are no rabbits. Assume that all the 200 of them are pigeons. Then each pigeon will have 2 legs and there will be altogether 400 legs. Now if you replace one pigeon with a rabbit, then there will be extra 2 legs. That is, if you remove one pigeon, number of legs will be 2 less, and if you add a rabbit, it will be plus 4. So minus 2 plus 4, you will have extra 2 legs. And for each pigeon that is replaced by a rabbit, you will have extra 2 legs. So for one rabbit, if you introduce one rabbit instead of a pigeon, you will have extra 2 legs. Now here the number of legs are actually 580 minus 400, altogether 180 legs are there. For each rabbit 2 legs. So for 180 legs there should be 90 rabbits. Number of rabbits will be 90 and number of pigeons will be 200 minus x. X is 90. So 200 minus 90, pigeons is equal to 200 minus 90, 110. So how many pigeons are there? 110, option C. A fitness fanatic can swim at twice the speed of a river. So let us mark the data here. So here we have the swimmer and this is the river. And the swimmer can swim at twice the speed of the river. So if you take the speed of the river to be x, then the swimmer can swim at 2x speed. So his speed is twice that of the river. He swims upstream to his destination and comes back, taking 4 minutes in all. How long would it take for him to do the full journey in still water? So initially he goes upstream. So first we'll find out his effective speed when he is going upstream. When he is going upstream, his speed will be 2x minus x, that is b minus r. So his effective speed will be x. And next we'll find out his speed when he is going downstream. Now when he is going downstream, his effective speed will be b plus r, that is 2x plus x. So the speed will be 3x. So here you can see that when he is downstreaming, his speed is 3 times that of his speed when he is upstreaming. Now when you triple the speed, the time required will become 1/3. So the time required for downstreaming will be 1/3 the time required for upstreaming. For example, if you take the time required for upstreaming as, let us say, 3y, then the time required for downstreaming will be only be y. That is, this is the time. This is the speed and this is the time. For example, if you double your speed, then the time required will become half. Similarly, if you triple your speed, the time required will become 1/3. In this case, his speed is 3 times the speed while he is upstreaming. So the time required will become 1/3. So if this can be taken as 3y, this will be 1/3 the time required, this will be y. And it is said that altogether he takes 4 minutes. So we'll just solve it here. This is the time required for upstreaming, that is 3y, and this is the time required for downstreaming, that is y. And the total time is 4y, and that is equal to 4. So altogether he takes 4 minutes, from which you will get y is equal to 1. 4y is equal to 4 minutes, or y is equal to 1, which means that the actual time for upstreaming can be taken as 3 minutes, and the actual time for downstreaming can be taken as 1 minute, because y is equal to 1. Now how long would it take for him to do the full journey in still water? Now look at this. When his speed is x, then the time required is 3 minutes. So when the speed is x, his time required is 3 minutes. Now when he is swimming in still water, his speed will be 2x. That is, while swimming in still water, his speed is 2 times that of the river, it will be 2x. Now you have doubled the speed. When you double the speed, the time required will become half. So time required will be only half of 3, that is 1.5 minutes. Now 1.5 minutes for reaching his destination, and another 1.5 to come back. So 1.5 minutes to reach his destination and another 1.5 to come back. So altogether 3 minutes will be necessary for the full journey. Hence option B, 3 is the right answer. Two trains of the same length but with different speeds pass a static pole in 4 seconds and 5 seconds respectively. Static means a pole that does not move. So two trains are there, that is train 1 and train 2. And the time taken to pass a pole is 4 seconds and 5 seconds respectively. Now to pass a pole means the length of the train has to be passed. So distance to be moved is the length of the train, and both the trains are of the same length. So to cover a fixed distance, that is the length of the train, one train takes 4 seconds and another train takes 5 seconds. So time required is in the ratio 4:5, which means that their speeds will be in the ratio 5:4. So if you take the first train speed to be 5x, second train speed can be taken as 4x. That is, a time required is in the ratio 4:5, then speeds will be in the ratio 5:4. Now this can be obtained from a commonly used shortcut method. So we will look at that shortcut method. So you have two people, A and B. Now assume that their speeds are in the ratio A is to B. If the speeds are in the ratio A is to B, then if they have to cover a fixed distance, both the people A and B, they need to cover a fixed distance. then the time required will be in the ratio b is to a. This is the shortcut method. So if the speeds are in the ratio a is to b and both of them need to cover a fixed distance, then the time required will be in the ratio b is to a. For example, if the, we'll just draw it like this. So if the speeds are, let us say, 2 is to 1, that is, the speed of A is twice that of B, then to cover a fixed distance, the time required will be in the ratio 1 is to 2. That is, A's speed is twice that of B, which means that to cover a fixed distance, A will require only half the time required by B. So if the speeds are 2 meter per second and 1 meter per second, then to cover a fixed distance, the time required will be in the ratio 1 is to 2. So you can take it as 1x and 2x. That is, you can see that A speed is twice that of B, then A will require only half the time required by B. For example, if the speeds are in the ratio 3 is to 1, then the time required will be in the ratio 1 is to 3. That is, if A's speed is 3 times that of B, then the time required will be 1/3 that of B. So we'll take an example. Assume that the speeds are of A and B are 3 meter per second and 4 meters per second. Assume that they need to cover a distance equal to, let us say, 12 meters. So let us calculate the time required. Time required for A is, we'll calculate the time required for A. Distance is 12, by A speed is 3, you will get it as 4 seconds. So A will take 4 seconds to cover the 12 meters. Next we'll calculate the time required for B. Distance is 12, by B speed is 4. So time required will be 3 seconds. So that will be 3 seconds. So you can see if the speeds are in the ratio 3 is to 4, then the time required will be in the ratio 4 is to 3. Or we can also say, if the time required is in the ratio 4 is to 3, then the speeds will be in the ratio 3 is to 4. Or generally, speeds are in the ratio A is to B, then time will be in the ratio B is to A, provided both of them need to cover a fixed distance. So here a time required is in the ratio 4 is to 5. Then their speeds will be in the ratio 5 is to 4. So you can take their speeds as 5x and 4x. Now consider the first train. Its speed is 5x, and when the speed is 5x, time required is 4 seconds. 4 seconds is the time required. Now the question is, what is the time required for the faster train to overtake the slower train? Now when they are overtaking, they are both moving in the same direction. When they are moving in the same direction, their speed or relative velocity will be difference of their speeds. So when they are overtaking each other, their relative velocity will be 5x minus 4x. Effective speed will be x. Then what will be the time required? When the speed is 5x, time required is 4 seconds. Now when the speed is x, means speed has been made 1/5. When the speed is made 1/5, time required will become 5 times. 5 times 4. That will be 20 seconds. That is, if you double your speed, time required will become half. Similarly, if you make your speed 1/5 as much, then the time required will become 5 times. Similarly, from 5x to x, the speed has been made 1/5 as much. Then the time required will become 5 times. 5 times 4 is 20 seconds. Now 20 seconds is the time to do the length of the train. Now the faster train is overtaking the slower train. So assume that this is the slow train and this is the fast train. Both of them have the same length. Now to overtake the slow train, first the length of the slow train t has to be moved. Then they will become equal, then its own body length t. So when they are overtaking, the total distance to be moved is 2t. Now 20 seconds is the time required to do the length of the train. Now when they are overtaking, it will be 2t. So the length has doubled. When the distance to be moved is doubled, the time required will again double. So instead of 20 seconds to overtake, now it will require 40 seconds. Hence option C, 40 is the right answer. A man loses 50% of his money. He then spends 50% of the remaining money. He is left with rupees 40. How much did he have initially? So assume that initially the amount that he had is rupees I. He loses 50% of his money. So he'll be left with the remaining 50%. So after losing 50%, now he has the remaining 50% of the initial amount I. And of this, he spends 50% of this. So he is left with again the remaining 50% of this. He has spent 50% of this, so he has the remaining 50%. And this is equal to rupees 40. He is left with rupees 40. So we need to find out the initial amount I. Here goes 2 times. Here also 50 divides 2 times. So I, you will get it as 2 into 2, 4. 4 into 40 is rupees 160. So the initial amount that he had is option B, 160.